Hello, everybody. Good morning or good afternoon. My name is Elham, and I'm going to present you the first part of this webinar. So welcome to this webinar, and thanks for joining us. Let's see what is RhinoLands. Basically, RhinoLands is a BIM standalone solution for landscape design. And when we say BIM, because it's BIM features that are implemented inside the program that help us to improve our workflow. So I'm going to present you the first part of the session, which is the overview and reviewing the main features of the program. And then my colleague, Francesca Saya, is going to present the live demo of the program, and we will see how to develop a real landscape project using the commands of the program. RhinoLands is a professional BIM landscape software. It helps us to have technical drawing in 2D, the 3D model of the project, then it automatically generates a list of plans and all hardscape tools. And then there are several tools for visualization and animation of the project. The program is a standalone, so it already includes. The program is a standalone, so it already includes Rhino 8, and with the next versions of Rhino, it will get updated. So as you see, there's a simplified interface of Rhino specifically designed and developed for landscape architects. So it starts from drawing, then drawing tools, and then modeling tools, standard modeling tools, then terrain generation tools, and then moving forward with vegetation and hardscape, irrigation, and documentation that you see here, and finally visualization tools. So Rhino includes a render engine itself. So finally, we can even have a rendering and realistic results by using Rhino render. Okay, so let's see how the program is used. Basically, it is for landscape architecture, but in addition, it is used for green infrastructure design used by civil engineers, for urban planning design, and for environmental projects. For example, we can easily model a forest by using the tools of RhinoLands. So let's see its main features. The program includes an extensive plant database and several tools for vegetation. As you see, the plant database includes several filters that help us to select the adequate plant based on plant type, flowering, soil type, or climate. And inside of plant database, there are several blocks for the same plant species that these blocks are going to be used in different display modes. We can create a new plant species or see the characteristics of a plant species and botanical information from plant database. So we have different display modes in RhinoLands, and as you see here, we can also shift between conceptual, detailed, elevation, or realistic mode of plant representation. In realistic mode, we have the seasonal representation, so we can see how would be the seasonal change of our landscape during the year. So in this way, we can visualize the same model, the same project in different seasons and see how would be the scene in different periods of the year. We can switch between 2D and 3D easily by one click. So as you see in 2D environment, we have a specific 2D blocks. And if you are used to work in 2D environment, you can continue drawing and using program commands in 2D environment. And then when you switch to 3D, you will see that in reality, you have a 3D model and vice versa. For inserting plants, there are several modes. We can insert them individually. We can move the mouse on the plot and insert plants randomly, like paint or windows. Also, we can convert any points to plants or any blocks, like, for example, AutoCAD blocks, the symbols of the plant. You can convert them to a realistic 3D plants in RhinoLands. We can insert a row of plants by indicating the distance between them and the combination of plant species, or insert a group of plants, again, by indicating the distance and the arrangement. We can insert shrubs by indicating the number of units per meter, per square meter, or per linear meter, or the number of ground covers, again, per area, per unit. Inside of plant editors, we have a plant editor, which is quite useful when you want to modify an existing plant model. So it's a free add-on. Another feature is we have this powerful terrain mode generating tool that you see. We can generate the terrain by points and lines. And once the terrain is generated, we can do pattern fields, create paths, and different types of operations. The program will save and calculate the volume of earth-moving operations one by one individually. We can generate the terrain by digital elevation models, DEM files, or generate a terrain just by indicating the location on the map. The program uses a global elevation database to produce the 3D terrain of selected area. So by using terrain tools, we can compare different alternatives for the same project and choose the more sustainable one, the more sustainable alternatives, for example. So in this example, we have two alternatives for creating a road between this building on top and the rest of neighborhood. And as you see, by comparing the result of field volume and big volume of these two operations, we can select the best alternative according to our criteria. So this is an operation that you can do in a couple of minutes, in a few minutes at least. Then we have dynamic documentation tools that help us to add tags to the plant species and to other objects. And we can have for example, the initial of the name, the quantity of each plant. We can add the image of plants by a specific comment and produce different types of documentation in this way. For example, we can continue to produce different sections, different plans, and add the dimension objects, elevation mark, or scale to the drawing. All listing tools are also connected to the 3D model, and you can update them automatically. We have parametric hardscape tools that help us to produce hardscapes like walls, edgings, ramps, or stairs. And all of these objects will be listed automatically by the program. We have also parametric fences, parametric stair, and also there's a block library for furniture inside the program. There are irrigation tools that help us to design the irrigation system by 2D objects, actually. So by placing the sprinklers and generating the pipe system, the program will list automatically the list of sprinklers and pipes. We have different visualization tools for including walk mode. We can walk through the project. We have sun and shadow tools that help us to visualize the shadow movement in our landscape. So by moving the slider, we can see in different hours of the day and in different months of the year, how would be the shadow movement, just by indicating the location of our project. We have also render options. There are different renders that are compatible with RhinoLands. And also there's a block library and there's an image filter for filtering the images. This is the rendering with Rhino Render. So even without using any external rendering engine, we can achieve this kind of realistic results by using Rhino Render. But these are the examples of other rendering engines. So RhinoLands by using Hardscape, Twinmotion, V-Ray, and Lumio. The project that you see here is a project that is made by using is modeled by using RhinoLands, and then the rendering is made by using Hardscape. In this way, we can bring our project into life. We have the big feature here is the parametric design possibility by using Grasshopper. So we apply a parametric design to generate algorithms and to use algorithms and generate a geometry, or we use algorithms and by applying Grasshopper, we connect data to a beam geometry and do different types of analysis. We will see the examples in the next slides. So these are Grasshopper components of RhinoLands. So any objects that we have in our landscape, like a row of plants or individual plants or a terrain, can be generated and can be automated the design process by applying Grasshopper. This is an additional an advanced level of using the program, but it is not necessary for beginners to learn Grasshopper, of course. So this is an example that we will see here is that we are going to insert a group of plants by different size or different diameters. And then we will going to have some plant pots with the same diameter of these plant models. So this is something that can be done by using a specific definition in Grasshopper. And since the definition is linked to the plant, we will have the same diameter of the plant. And by moving the plant, everything changes automatically. So, well, this is a simple example, but we can imagine how would be the possibility and how big is the potential of applying Grasshopper in landscape design. Another use of Grasshopper that we developed and we promote here is applying Grasshopper for doing environmental analysis. We link environmental data through Grasshopper to our beam model. Since our objects are parametric, so everything can be done automatically. So this is the basic. And then the result that we get from by using this workflow is that, for example, we can calculate how much carbon will get sequestrated by implementing this park or this project, this landscape. So how much would be the cooling effect of plants on the surface? And we can do also shadow analysis and solar radiation. So we know how much solar radiation will get absorbed by different plant species and by different parts of the same plant model. These are the solar radiation, for example, is the result of connecting RhinoLands to Ladybug tools, which is a specific tools, a free plugin for calculating environmental data in Rhino environment. So this is the workflow that we have published and we have developed recently. This is the carbon calculation, the carbon sequestration calculation. So in the left side, we have a model, and in the right side, we have this calculation. So we can indicate the age of plant species, and by moving the slider, then we will get the final result of the carbon sequestration in different periods of time. We can also show that graphically later on. The next feature is a beam workflow. What you see here is Revit environment. So we can call our landscape model into Revit environment, and all its smart beam objects will recognize by Revit as beam objects. Another workflow in beam environment is the IFC support. So you can import or export your model into IFC file format and open it in any other beam program. So let's see how would be the design process using the program. We may have some topographic contours, so we can convert them to a terrain inside the program. Or we don't have any topographic information, and we generate that by importing by selecting on the map. Once the terrain is generated, we can do different types of operation like cotton fields. So we will have different surfaces here. And then we can continue by adding the hardscape elements like walls, surface, fences, stairs, and so on. All these objects are parametric, so after inserting them, you can change its size or its distance or whatever. And continue, we add urban furniture to the project by using the block library inside the program, or by importing any other blocks that are compatible with the program. For example, we can import a SketchUp file. And continue, we insert the vegetation. So by using the plant database, we select the plant, the adequate plant of our project. And as you see, well, these are 2D blocks of the same 3D model. So we are more comfortable to work in 2D maybe. So we continue in working in 2D environment. And then, well, as you see, there are different arrangements for the plant. Then we can continue by documentation steps. So we add the labels of plants and the name of them. We can tag the name of them and so on, or adding the image of plants and inserting the list of plants, walls, furniture, the list of earthmoving operation, and the other lists. Finally, if we shift to 3D, we see the seasonal change of the same project, as you see here. And we shot a render to have the realistic result and the rendering at the end of the design process. So let's see how would be the workflow by using the program. Basically, RhinoLands is a standalone complete program. You can do everything from drawing until documentation inside the program. But in case that you have some CAD files or some CAD drawings like AutoCAD files or SketchUp files or this kind of file formats, you can open them in RhinoLands and then continue working and modeling. In continue for visualization, you can apply a render that is compatible like Enscape, V-Ray, Twinmotion, or Lumia, or use the virtual reality headsets, or print your project with a 3D printer. For documentation, you export the lists that are generated by the program to Excel or to PDF. And also you can produce your layouts inside the program. You may have collaboration with other programs. You can import or export models from RhinoLands to Revit or 3D Max or ArchiCAD, for example. You may have also the possibility to import GIS files inside the program. So GIS files, DEM files, or point clouds, or LiDAR point clouds, you can open them in RhinoLands and continue working there. So in summary, the whole project can be done by using RhinoLands. It means that you will produce different type of plans, conceptual plans, dimension, planting, and so on. You can produce different sections and views of the program, of the project, and then also you have the 3D realistic model of the project. This is a real-world application of RhinoLands. As you see, this is a green infrastructure in Madrid. And all these documentations, these models are made by using RhinoLands. And well, in summary, we have a 60-day free trial. The licenses are two types, are permanent license or subscription option you can choose. We have free technical support, so feel free to contact us for any issue, any technical issue. And there are educational and lab licenses for students and for teachers and schools at a very reduced price. I don't know if now is there any questions, or we can move forward with live demo.
Hello, hello everybody. Hi, Elham.
Hi. Now
there is a question in the chat. Says that if the sun shadow simulation only use it for visualization, or can the data also use it, for example, to understand how long the sunshine on each land per day at one or similar? Well, maybe we can see that in a live demo. So we'll see how to interact with the sun tool. So I'm going to share the screen. And then eventually at some point, we will show this sun tool that is actually native in Rhino, but also in RhinoLands can be used. Okay. All right. So we can see here a model, okay, a made model, but let me go one step backwards. So imagine a situation where we have an empty file And well, first of all, I'm gonna show an overview of the interface. I would like to know if any of you is familiar with Rhino already. Please, if you can just leave your comments. But if you are familiar with Rhino, you may find this this interface familiar too, because it's a simplified interface of Rhino. But we have selected the most essential commands to develop landscape projects. Okay, so if we explore all these tabs, we'll see that we can find here all the 2D tools necessary to draw in 2D and also edit 2D objects. Okay, we can find familiar tools like hatching, offset, etc. If we follow with these tabs, we can find here all the 3D modeling tools, from creating surfaces to 3D primitives, but also commands to extrude curves, extrude surfaces, chamfer, fillet surfaces, do Boolean operations. So all the necessary 3D tools to operate with these 3D objects. Okay. If we move on, we can see here the terrain modeling tools. So as we have seen in the presentation, we can import terrains from the cloud, also from DEM files or GIS files. And we have here some commands to create new terrains as well and do operations on these terrains. I will see some of these features in a moment. Now we have here all the vegetation tools to insert plants in different ways, as we have seen as well. We have here all the civil work objects. Okay, they are parametric objects that very easy to modify and edit through parameters. Here we can see some of the irrigation tools that RhinoLands provides. Moving on, we can see all the documentation tools from all the listing tools that will show all the information of the elements in the model, to well, the typical drafting tools to dimension our project or to work from the page layout. Okay, we have quick access here to move to the page layout, add new details, and prepare our shop drawings. Finally, we have visualization tools, basically change the viewport distribution or change the viewport position, okay, or also change the display mode in each one of these views, okay. And finally, we have some commands to select object by type. On the left hand, we can see here some quick commands to move, scale, rotate objects. So these are like the everyday commands that we can use while we're modeling. And from the right side, we can see the edit panel, the RhinoLands edit panel, that will let us work or change the parameters of the objects that we select. We'll see that in a second. Also here we have the most typical panels also existing in Rhino. So they are a selection of them. We can see how to work with layers. Okay, so we have the layers panel. If you are familiar with AutoCAD, RhinoLands has the same, let's say, layer manager, to visualize objects by layer, change attributes, materials, line types, print width, and so on, and some other tools that we will explore. And also in this top toolbar, we can find some zoom options, the typical save, copy, visualization tools, okay, that we can find any 3D software. So, but let's imagine a situation where we get a DWG file from the client or from a collaborator. So we want to import that into that file. So we just need to go to Open, then select any DWG file like this one. And as simple as that, we have some import options. We can just select the default ones. I'm not going to go into detail right now for this, but the idea is that you have 2D curves that exist in the model. From the layer manager, we can switch them on and off, and we could start modeling the 3D project on top of these curves, okay? So now we can go back to that project that's the same as this DWG file, but a little bit more developed. And we can follow the development of this project, seeing some of the RhinoLands main features. So let's start with the terrain modeling tools. Okay, imagine a situation where we have also the DWG files, DWG curves, and we want to create a terrain out of them. So the first thing we need to do is to elevate this curve, right? Well, just before showing the terrain, let me show also the different display modes that we have seen in the presentation, but we can also see it live here. In this project, we're seeing the plants in realistic display mode. Okay, so we can, that's what we have selected here, but we can also see other representations like detailed, conceptual, and the elevations. Okay, also these projects can be displayed in 2D. So all the objects have a 2D representation or in 3D. Okay, also there is a specific symbol for the plants. Okay, setting out symbols or 2D crowns, and then we have this hatches option to show or hide hatches for these crowns. Okay, so this 2D and 3D view can be displayed for all viewports at the same time, or we can just uncheck this button, and we can have like individual level of detail in each viewport. For example, in the top viewport, we can see them all in 2D like it is now, but in this 3D, we can show the 3D representation in this perspective view, and we can activate the realistic display mode. In side views, maybe we can show that in 3D and show the elevations. And in this one, maybe we can show also in 3D in realistic mode, or maybe in just in conceptual mode. Okay, so this is up to you how you want to display the project representation in each viewport. So also from this edit panel, we can see the list of all the species that we have in the model. We can select them from here, and then we can add changes to the different representation modes for each species. Okay, so we can browse here for the in the library of 2D crowns to select another 2D representation for this species. There are many blocks, and actually you can add your own 2D crown into this folder. It's nothing but a 3DM file. Okay, and you can do the same for the other representation modes. Okay, so well, let's back to the generation of a terrain. So as I was mentioning, we can start with some contour curves like these ones, but in this case, all of them are in the same elevation. Okay, so the first thing you want to do is to elevate these curves into the desired position. So when we create the terrain will adapt to the elevation of these curves. And there is here a specific tool to elevate curves according to an interval. When we run this command, we need to draw a line, and all the curves intersecting this line will be elevated according to an interval. Okay, so well, we define the increment of 1 meter, start dimension set to 0, and we'll click apply. As you can see, all the curves are elevated. Okay, we can modify this to another value. If we click apply, we will see the changes. So we click apply until we are satisfied with the results, and then we can close and have all the curves elevated. Okay, so in big projects where we have like dozens of control curves, this is very helpful, believe me. Now we have the curves in the desired position, so we just need to run the terrain command, select the curves. Just notice that in RhinoLands, every time you run any command, just need to follow the instructions in the command line. Okay, so they are very intuitive, and without any experience, you can just try, follow the steps, and discover all the functionality that is available in the program. Okay, so we need to select the curves. You can also include points, so terrains can be created from a combination of curves and points. When you're done, click enter. So we get this insert dialog where we can define the level of detail of the mesh, of the resulting mesh that will be used to generate the terrain. So the smaller this grid surface, the cell of this grid surface is, the more accurate it will be with the input data, which are those curves. And also here from the contour lines tab, we can define how many, the interval of 2D contours. Okay, we can also enable an index every certain number of contours. Here we can control the text size if you like. Okay, and when you are done, click OK, and we will see the terrain generated on top of this, of these curves. Okay, the terrain takes kind of extension of the bounding box of these curves. So we may need to use a command to trim this terrain from a desired boundary curve. But first of all, let's take a look at the features of this terrain. So when we select it here in the edit panel, we can change the size of this terrain. Okay, so we'll get more accurate terrain. We can enable a base if you like, define the thickness of that base. And well, here under the input data, we'll see all the contours. Just notice that all the control points of the curves that we have used for this terrain have been absorbed by the terrain. That means that we can modify the topography of the terrain by pulling up and down these control points. Okay, so the terrain will be modified according to these controls. And all the operations that we do on the terrain will be stored into this input data. So that means that it's fully parametric. We'll be able to edit that at any time, delete any curve to see the terrain reconstructed. Okay. Now we can see that some part of the terrain is overlapping with these zones. So let's see this in wireframe for a second. And here I've got a boundary curve, and I'm going to use that to trim the terrain. Okay, just to adjust the boundary of the terrain according to that curve. And we have a command, specific command for that. It's a terrain boundary. So we run it, and again, we follow the constructions in the command line. We select the terrain. Now we select that closed curve, and that's it. Okay, we can see this back into a rendered mode, or actually we can enable the render display also from this button, like here. Okay. Now, just notice that all the plans, all the elements that we draw now on top of this terrain will be projected on top of it. So if we move these, for example, these plants, okay, this is actually a forest. But if we move this forest to another position, all the plants will adapt to the new topography, okay, to the new elevation of according to the terrain underneath. Okay, now let's see some of the operations we can do on this terrain, and I'm gonna show a curve that I've got under this layer. Okay, here it is. So I've got here a curve. Maybe I'm going to show this in wireframe. So I can select this curve, and I'm going to create a path on this terrain following this curve. So the terrain will adapt to the elevation of this curve in order to create a path according to a width. But the first thing I'm going to do is to elevate or adjust this curve to the existing terrain. Okay, so it's as maximum accurate to the terrain as possible. So now it is adjusted. I'm going to show this back to render it. And now we can run this command, path command, select the terrain, select.
Hello.
So we pick an angle that will actually be the angle in which the path of the terrain, the path meets the existing terrain. And finally, select a curve. As we can see, the path is now generated here in this curve. And as we did with the topography curves, we have integrated the control point for this. Okay, select it again. So we have a grip point at the end of this path to modify the position of this start point of the path. Okay, maybe sometimes it's better to switch display modes to select that grip properly. Now we can just move it down. Okay. Another operations we can do on the terrain, for example, I've got here a curve. I'm gonna select it in wireframe. And imagine that we want to flatten the terrain according to that curve. So I'm gonna elevate it a little bit. So part of it it's inside the terrain, and part of it it's outside. Okay, maybe now we can see it better. So there is this command, the cut and fill command, where we select the terrain. Again, we select some slope angle. For example, in this case, I'm gonna define it as 75 degrees. And you can also choose if you want to divide the this cut and fill area or not. This will let you assign different materials. We say yes and pick a curve. So now the terrain is flattened on that area. Okay, if we see this back in rendered display mode, we can select the terrain. And now from the edit panel, we can see here the two subdivisions that we created. First one for the path, another one for the cut and fill. And if we select any of them, we will be able to assign a material. So we can choose the same material as the terrain, or select a texture either from any material that you have in RhinoLands. If you use V-Ray, if you use other plugins, you can also use the materials provided by these programs. Or you can select an existing texture from the RhinoLands library. Okay, maybe we can pick here kind of a gravel, or it's kind of a stone, but anyway, will give us the feeling that it's a gravel. Okay. All right, and all these operations that we're doing on the terrain, again, they are stored under this input data tab. Okay, so we can select any of these subdivisions, create a zone out of them. We can select that, change the slope angle. We can select the path, for example, and change the width. So let's see some of the tools with vegetation commands. Okay, so we can insert some plants and arrange in different ways. So when you run, for example, the plant command, we get this insert dialog. In this case, we can see the existing species that we have already used in this document, but of course, in an empty file, you would have this list empty. And then select the browse button to open the plant database. And here you can search for any desired species by selecting all these characteristics and all these filters. Okay, here from the top, from the header of the dialog, you can see how many species match with all these filters. Okay, you can clear that and see this number restart. Okay, there are already some groups of species, so you can also see your favorites. I mean, all the species that you select here by clicking on the heart icon are your favorites. Okay, and then you can filter the species that you have selected as favorites. There are also some plants that have a specific realistic representation designed for that species, and you can see them grouped under this with render name. Okay, but you can see also some species that are suitable for vertical gardens. They are also put into this specific list. All right, and there are many filters and criteria to find your desired species. Okay, and showing all, you will see here all the plant species available in the plant database. You can also search for one specific species by typing here the common name or the scientific name. Okay, so for example, we can select a lemon tree in this case, and you can also create new species. I mean, you can start a new start from scratch. With this button, you will start an empty sheet where you can fill all this form to provide all the details of the new species. And here on the display, you would assign a 2D crown, a 3D shape for the conceptual representation, same for the 3D representation, same for the realistic 3D shape. Okay, these are files that can store different representations according to season. Okay, and well, you can add here new species for your projects. Okay, or you can start from a copy of an existing one and modify the copy. Okay, so we select the lemon tree in this case. We define the size of that plant. The natural operation will make that all the plants, all the instances we create, they are slightly different in height from one to another. And same for the rotation. And this will make the plants look different. Okay. All right. And now we can select the plants, go to the edit panel, and here we can modify the size, we can modify the species. Okay, we can do any change that we want. Another way to create insert plants is arrange it in rows or in forests. For example, from the top viewport, I'm going to show this in 2D, and we can create a forest by selecting the species. I'm going to select maybe cedrus in this case. Here under the forest tab, we define the number of units or the minimum distance of the units, and we can select a boundary curve for the forest or any of these options to draw it on the fly. So we can select the polyline. I'm going to disable the OSNUPs, and here we can define the forest perimeter. Okay. Now, when we see this from the 3D view, we can appreciate that all the plants have been already projected on top of the terrain. Okay. And we can select that forest and select the plant tab, change the size of the plants, and change any parameter referred to the plant. While if we select the forest tab, we can change the number of units, separation, select maybe an array distribution, ordered array distribution here. We can also combine elements. If we click in this button, we have now two species hanging from this forest. So we can select one or another and change the species of it. Okay, and well, adjust the parameters for these species. Okay. All right, so all these species, as well as other elements, can be listed in lists. So I'm gonna insert one now. Since we have created a few plants, I'm gonna move to the documentation toolbar and insert a plant list. Okay, and this is a list that is linked with the 3D model. That means that if we gonna move it next to it, if I change, for example, this plant row that is generated with cedrus, we can see that we have 30 units. But if I change the number of units to 6, you can see that this number has updated. Okay, so it's a live list connected with the 3D model. Okay. In a similar way, we can insert zones lists, terrain movement lists, okay, and other kind of lists. For example, here we have a few zones that will tell us the area, the total area of each according to boundary curves. We can create a new zone for this rectangle, for example, with the zonify command. We can either select one inner point inside an empty area, or select this boundaries option in the command line to select a closed curve, and you just give a name for the label, define a hatch pattern for the zone in 2D, and also we can choose a material for the 3D representation of the zone. Click OK, and we have this zone created here. And now we can also insert a zone list. So if we select this list, we can see here all the parameters that we can change. We can maybe show the density also, show the initials. So you can customize the information displayed in this list. And you can also select, add some filters. For example, we can define the units or the plants that we have inside this list according to a perimeter. So imagine that we want to use that boundary curve that we used for the terrain boundary to display only the species that are inside that area. So we can activate the filter by region at the boundary. So I'm going to select this boundary. And now here we will just see the plant species that are on top of the terrain. Okay. So all these options are very, very helpful to create different lists by zones or by boundary curves or by layers. We have also the option to filter plants existing in one layer or another. These plant lists are, as well as the other lists, can be exported. Okay, so we can export that to Excel or XML files. Okay. All right, now let's see some of the civil work elements as well. We have here some walls, fences, stairs, ramps. Maybe I'm going to show now you the ramp object because it's a new feature in relation to the last version of Lands design. And I'm going to insert a ramp in here. So I've got here a stair object. I'm going to change the width of this and change also the alignment. So I have the stair aligned to the right. And now I'm going to insert here ramp. So you can define ramps created as a masonry or a floating. And here you define the height, and the height is defined by a specific value or as a percentage or a proportion between the raise and the ramp. So in this case, I'm going to select the height, click OK. Now you can select any existing curve to create the ramp. That means that you can have like ramps with curved paths, okay? But in this case, I'm going to select polyline option, and I would select the justifications left to left and create the ramp in here. We can see here the slope of this ramp, and in 3D, we can see how this looks like, okay? For the, well, the wall tool, it's quite similar. We define the wall with as a parametric object that has a thickness and a height, and also with a justification, we can just with a polyline draw a wall at any place.
Well, in meantime, I'm going to ask a question which is running in chat about the least calculation, about the cost calculation of the project. Well, the program give us the list of, for example, walls and edging by total amount, right? So about the cost calculation, we need to have the price of the unit. So this is the step that we export our list to Excel and then do that kind of cost calculation manually, because we cannot provide the price. The program is the global program, so it's well, the price changes in every region, right? So yeah, you should export the list to Excel and add the price. Or if you have, if you are collaborating with Revit and you have, and in Revit you have set the price per unit, so just import the model into Revit by using lands inside Revit definition, grasshopper definition that we have published. So by importing in that way, Revit recognizes all walls and surfaces and earth moving operation as the topography. And then, well, you can get the calculation in Revit. And also there's another question about all AutoCAD, all Grasshopper plugins. Yes, you can link all your Grasshopper plugins to RhinoLands model.
Yeah, exactly. When you run Grasshopper, all the plugins that you have available for Grasshopper will show up in here as well. And actually, we are seeing the RhinoLands interface, but I mean, you can also install Lands Design as a plugin for Rhino and use it in the Rhino regular interface. And you will see here all the commands of Lands Design on top of Rhino and just work with the same tools, but in the regular, Rhino interface.
Is there any difference between the Rhino, the plugin for Rhino and then the standalone software? Do they have all the same functionality?
The functionality is the same. It's exactly the same. The only difference is the interface that's simplified, and most of the commands are hidden. But I mean, here if you type any command, you will see here, all the commands available in Rhino are also available in here.
Thank you.
All right. So there was a question about the sun panel first. I don't want to forget about it. So yeah, that's also a tool available in Rhino, as you may know. And based on a localization of your project, you can, do some kind of simulation based on that. And then just by, selecting a moment of the year or a moment of the day, you can have a rough, simulation of how the shadows will be projected on your project. Okay. All right. So I would like to finish with showing the animation tools. Okay, the animation commands. There is a specific panel for that. There is the animation panel, okay, available from this list, and this will let us, create short animation of the project already here in RhinoLands. So, but before that, I also want to show you the wall mode option. It's a command that puts you onto the ground, okay, and this will let you navigate through the project with a mouse cursor. So wherever you point, you will change the direction of this wall mode. With the mouse wheel, you can change the speed of walk. Okay, so it will feel like you are in a video game. Okay, you hit escape key to exit this walk mode. And now I'm gonna activate a layer where I have camera path. Okay, and I'm gonna use this curve that we have here as a camera path. So from the Lands Design animation panel, we can click on this button to select that curve as a camera path. Here we need to define the frames per second or the total duration of the animation, and we have other camera features here. Or you can select whether you want to use the Rhino display or the current renderer. That means that if we are using V-Ray or the Rhino renderer, after defining the folder where we want to save our animation, a video will be created, okay, generating a render for each frame of the animation. Okay. If you just want to see the quick preview of the result, you just select the Rhino display, okay, and click the play button to see how the animation will look like.
Well, you can also hide the curve.
Yeah, of course.
Selecting.
You hide the layers you want, and you can record this animation using the Rhino render display, which is quite nice already, or use the Rhino render.
Well, let's see we have a few minutes. Just let's see the layout, maybe.
Yeah. So yeah, I mean, if you are familiar with Rhino or maybe AutoCAD or other similar programs, I mean, you can work with paper space, okay, where you have, let's say, details, which are windows to the model space. I mean, we can click inside, and this is kind of a viewport of the model space, okay? We can show the model from one point of view or another. We can show an elevation or a section in each one of these details, okay? And actually, I think this is just a curve, but if we add a new detail here, maybe we can have like a viewport to the report, some of the report lists.
In the meantime, I'm going to answer a question about the Lands design and RhinoLands again. Lands design is a plugin as it was before. It will be existing and it will get updated. So Lands design is the plugin format of RhinoLands, and RhinoLands is the Lands design combined with Rhino 8 at this moment. And later on, it will combine with Rhino 9. So with the next version of Rhino, it will get updated. The difference is that RhinoLands is a standalone, so it already includes Rhino, and it has a simplified interface. Lands design is a plugin, so you need to open it in Rhino interface. So for new users, for beginners, it is more complicated to start learning Rhino with all its tools, toolbars, and its interface. So the easiest and the best way for beginners is to start and to continue working with RhinoLands. But for professionals and the Rhino experts, of course, Lands design as a plugin would benefit them. Okay.
There is a question about .NET. I mean, can RhinoLands objects be accessed if creating Rhino extension using .NET? I mean, there is an API available for the elements. In this case, I would suggest you to write to our support email to figure out exactly which functions, which what you need to do, and let you know what's available from the API to work with .NET.
Another question is about the vertical garden. Actually, we have a specific models of plants for vertical garden inside our plug library. So if you are going to have a vertical garden, you can filter our plant database by selecting vertical garden filter, and then cover that vertical surface by plants in their vertical model. So there are a list of plants that have two different models. One model for normal regular form, and another model which with more hanging leaves and hanging feature in vertical form. So yeah.
I mean, also, when you create forests or ground covers, for example, you can select a curve that it's in the vertical position. So the plants or the ground cover plants will be created on that vertical plane. And we will give you the feeling that you have created a vertical.
Maybe you can open the plant database to show that filter.
Yeah, I mean, I can just quickly, just a side, create some ground cover on an area. And maybe I can work from the 3D.
Okay.
Here it is. And yeah, for example, I'm gonna create a ground cover. Select some species that are suitable for the ground cover, or here we could select
vertical.
Yeah, well, this list is not available for the ground cover, but yeah, maybe we can choose a forest instead. So browse plants suitable for vertical garden.
Can killing the name of lemon.
Yeah,
yeah.
Exactly.
And you get, yeah. So go to one of them, yeah, to see just, yeah. As you see, there are two different models for the same plant species. One is for vertical garden. Okay. So it has the orientation and the right orientation, and everything is set for using that in that form. So another question about the shadow analysis. It's again, well, the question is getting deeper. So if you want to have like a heat map based on the location of plants or other objects, you can do that by using Ladybug tools. I mean, you link your RhinoLands model to Ladybug. You can install Ladybug on top of Rhino and run that simulation.
Yeah, exactly. I mean, you run Grasshopper, you have Ladybug tools, and you can link the 3D model with these tools to to do more detailed, environment analysis. Actually, you can reference all these elements in Grasshopper, and the plants can be exploded into meshes. So with the resulting geometry, the resulting meshes, you can do whatever you want with Grasshopper. Same for the terrain. It's nothing but a mesh, but you can use this mesh to run any analysis that you like.
Then Steve is asking about how each tree sprouts from the ground. Plants do not grow straight up, they lean to one side or another. Yeah, that's true. If you are asking about the vertical, I think vertical garden, right, Steve? Can you open your mic?
I'm talking about if you create a whole group of trees in a forest, can you indicate how each one leans within that forest so they're not all pointing straight up?
You need a full control.
So it looks more natural. So yours are very uniform and they're straight up. So anything in nature is not perfectly aligned straight up.
Yeah. Right.
Is that an option now available, or is it something you're developing, or have you not thought about it?
I think
Yeah, this feature is available for individual plants, but not for the plants in forest. Okay, you can inclinate, I mean, you need to...
You have to do each one.
Sorry?
You have to do each one if you want to get
Yeah, exactly. You need to rotate them individually. Yeah, exactly.
You might want to consider putting that in as an option if it's possible. To make it more...
Yeah, of course. We can take that into account for future versions. Yeah.
Do you think is it something necessary for a group of plants, Steve?
Right. Just from a natural look.
Okay. Well, there's a feature maybe we didn't see today, but there's a natural variation feature. I don't know if you have mentioned, Francis.
Yeah. I mean, when I was inserting the lemon tree, I mean, if you have the natural variation option,
here,
it will make that all the plants look different in size from one to another. Okay. So when we run any of these commands to insert plants, as long as we have this enabled, they will be different in height. Okay, but they are all vertical. They are all placed vertical. You can also choose a random, rotation. So different rotation, but they don't take into account the slope to inclinate the plant.
Okay, thank you for that.
Thank you too. Well, any other questions? Not so far. Well, thank you everybody for joining this webinar. Thank you, Francis.
Thank you.
Feel free to write us about your questions if you have any specific concern about the program. And I really suggest you to download the trial of the program. You will have 60-day trial, so just try it out by yourself and let us have your feedback. Thank you very much.
Thank you. See you soon.
Bye-bye.